Hey, my name is Jeremy and I'm an engineer here at Evervault. In this video, I'll show you how to start voting payment cards and use multiple payment service providers with Evervault. This can be achieved in just a few minutes with minor changes to your existing code. As your online business grows, you may want to add redundancy to your payment infrastructure by integrating an additional payment processor. You may also be looking to expand to new geographies and process payments domestically with a local acquirer. However, collecting and storing customer card data in-house is expensive for any business. Because you'll start handling card data, you'll have to comply with things like PCI, which can easily cost you a lot of time and money. This is why payment service providers like Stripe typically provide a way to securely tokenize card details. This can be done by embedding a payment form that they host or by redirecting users to their website. Because your provider is tokenizing and storing card details on your behalf, you won't be able to use the collected payment information with any other payment platform. You're basically locked with their own solution, making it very difficult to integrate with additional providers. That's where encryption can help. Evervault allows you to collect card details using Evervault Inputs. Inputs is a fully customizable payment form that you can embed in your web application and that encrypts all card details entered by your users in the browser. You can then safely send that encrypted data to your API for storage or processing without ever touching the plaintext value. When payments need to be processed with the PSP, requests can be sent through Outbound Relay, Evervault's decryption proxy. Outbound Relay will decrypt any sensitive information present in requests and forward the decrypted request to the provider. Because now you have full control on how card data is encrypted and decrypted, you can super easily add additional payment service providers to your existing infrastructure. I'll now show you how to update your code to start encrypting and decrypting card information with Evervault. You can see here that I've spun up a sample Node.js application running in Replit, which is an online IDE that I'll use to edit and run code directly from my browser. This simple application currently allows us to collect and tokenize card details in the frontend using Stripe element, send the tokenized card details to our backend, and process a payment of €1 on Stripe. I'm now going to update this code to start encrypting card details using Evervault instead of tokenizing them with Stripe, and use those encrypted details to process payments across multi-payment service providers. I've just created an account on Evervault, which is totally free. You can create an account on evervault.com. There, I'll just create an app called Payment Demo that I'll use for demo purposes. Once the app is created, I'll go back to my front-end code and import the Evervault JavaScript using js.evervault.com/v2. I can initialize the SDK by passing two parameters. My Evervault team ID, which is the token starting with team_ that can be found in the URL of the Evervault dashboard, and the app ID that can be found in the settings of the app I just created. I'll then initialize Evervault Inputs to create a fully customizable payment form and replace the current Stripe element form. To do that, I'll pass the ID of the DOM element I'd like the form to be rendered in this case, card-element. I can now update the callback function that is invoked when the checkout button is clicked. In there, I'll comment out the logic that is used to call the backend, just for debugging purposes for now. Once that's done, I'll fetch the encrypted card data from Evervault Inputs by calling the getData method and store that in a variable. I'll now print the content of this variable so we can see what inputs returns. I'll refresh the front end and it will input some test card details. As you can see, we've successfully received encrypted data from inputs like the card number, the CVC, etc. I can now update the logic in order to send the collected encrypted data to the backend so we can start initiating payments there without ever touching the plaintext value. Our backend consists of a light Node.js server that listens support 8080 and creates a €1 payment with Stripe using the card token generated in the front end. I now want to update the logic so that we retrieve the encrypted card details that we've just sent from the front end. We'll also slightly update the logic used to create a payment with Stripe, where we'll send the card details instead of a card token. In its current state, our small application sends encrypted data to Stripe, which they wouldn't be able to use or understand. As a result, we need to start routing all requests sent to Stripe through Evervault decryption egress proxy called Outbound Relay. To do that, we'll import the Evervault Node SDK and initialize it using our app API key. This key can be found in the Evervault dashboard in our app settings. We can then invoke the enable outbound relay method to override the node HTTP module to route specific requests through Evervault's decryption proxy. Next step, we need to enable outbound relay on the Stripe domain so that all requests made to the Stripe API are routed through the decryption proxy. This can be done in the outbound relay section of the Evervault dashboard. We can now restart our application and make a test transaction. I'll input our test card number in the payment form and press checkout. This will encrypt my card details in the front end, send the encrypted data to our backend, and initiate a payment of €1 with Stripe. As you can see, the payment was successfully made on the Stripe platform. We now want to implement an additional payment service provider to, for example, start acquiring domestically in new geographies. As you can see here, I've already implemented the logic to initiate payments with checkout.com, another payment service provider. Now I'll write logic to initiate some of my payments with this new provider. In this case, we'll route all payments made with a card that starts with 424242 to checkout.com. I can now enable outbound relay on all checkout.com subdomains so that all requests sent to this domain are decrypted by Evervault egress proxy. We'll restart our server and try to run a payment again. I'll input the test card number again and press checkout. As you can see, we've now successfully processed another payment on another PSP. And this is how you can start vaulting cardholder data and processing payments across multiple payment service providers using Evervault in exactly 5 minutes. You can implement this by yourself or try some of our other encryption capabilities for free on evervault.com. Thanks for watching.